So we're going to be looking at two different problems in this video. The first one is going to be taking a dual minimum problem, and writing it as its dual maximum problem. So the first thing we need to do is make sure that our minimum problem is initially in standard form. And so we see here that our objective function has all positive constants, which we need. The next thing we need to check is to make sure that each of our constraints is set greater than or equal to some constant. So we have that as well, as it's set greater than or equal to 4 and greater than or equal to 1. And each of our variables is set greater than or equal to 0, meaning that they are non-negative entries as well. So now what we're going to do is take this information and write this in an augmented matrix. And so we're going to make sure to write our minimum objective function, as our last row. So we're going to start with the constraints. So we just write how we would write any other augmented matrix. And we make sure to write our objective function last. And so here, usually when we're writing a matrix for our simplex tableau, we're going to have 0 here because we're going to have set our objective function equal to 0. But instead, we're going to leave it as it is. So we're just going to leave a placeholder here. So I'm just going to use that as my placeholder right there. Just a 0 with a dash through it. And that doesn't mean that's equal to 0. That's simply our placeholder. And so now what we have to do is find the transpose of this matrix. And so we see that this is a 3 by 4 matrix. And when we're finding a transpose of our matrix, it's going to end up being a 4 by 3 matrix over here. So our transpose of this matrix now a 4 by 3 matrix. And all we're going to do is take the rows of this matrix and write them as the column of this matrix. So I'd like to just start by taking the first row and writing it as the first column. And then the second row as the second column. And finally, we have our final row is going to be our final column. And again, we're going to keep our placeholder here. This is not 0 again. So what this tells us is that we can write our maximum problem using this information. So again, for our objective function, we're going to look to the last row. So that tells us that P is going to be equal to 4, and we're going to use different variables than what we had over there, because now, and we'll see this later on, that our variables that we're solving for are going to be different. So we have 4y1 plus y2, and this is going to be subject to our constraints, which are going to be coming from our first 3 rows. So that gives us 2y1 minus y2 is less than or equal to 5, because remember, when we're having our maximum function or maximum problem, we need to have everything less than or equal to a constant. So negative 3y1 minus 3y2 is less than or equal to 3, and y1 plus y2 is less than or equal to 2. And as always, we need to have our variables greater than or equal to 0, as they cannot be negative. So they have to be non-negative values for our variable. And so that is now our dual maximum problem for our original minimum problem. And so now we're going to look at our second problem, which is not a continuation of that one. This will be a different simplex tableau. So if you solve that problem, you would not end up with one like this. But we're going to look at this, and this is our final simplex tableau for a dual maximum problem to a minimum problem. And we're going to use this to find our answers. So usually when we're reading a final simplex tableau, we look at our basic variables over here, and then look to the right-hand side, and that will tell us the value of whatever this entry is over here. So that would tell us that S1 equals 11, Y1 equals 12, and P equals 13. But since this is a minimum problem that we're actually trying to solve, we're going to just look at what our S1 and S2 variables are. Whatever is in the final row under these columns is actually going to tell us what our X1 and X2 are. instead. So we're not even going to have to worry about whether or not these are basic variables or not. So actually, what we're going to end up with is x1, which is represented by s1 here, is going to be 0, and x2 is actually 10. And finally, the most important number, usually, for business at least, is going to be what our C value is, which again here, we have P, but if we're thinking about this as a word problem, that would be profit instead of our cost. And so it's going to be the same value, and we're going to still look over here to solve that. But again, this is going to end up being our cost instead of our profit. So the main thing to remember here is that our S1 and S2 are actually going to be X1 and X2, and we just look to the objective row for that.